What is an automatic expansion valve? An automatic expansion valve, AXV, also known as a constant pressure expansion valve, is a refrigerant metering device used in refrigeration and air conditioning systems to control the pressure inside the evaporator. Its primary function is to supply liquid refrigerant to the evaporator in such a way that the evaporator pressure remains constant, regardless of changes in cooling load. The automatic expansion valve does not respond to temperature or superheat like a TXV. Instead, it operates solely based on evaporator pressure. By maintaining constant evaporator pressure, the AXV ensures that the refrigerant changes its state from liquid to vapor at a controlled and steady pressure. This makes it suitable for systems where the cooling load remains nearly constant. Construction of automatic expansion valve. The construction of an automatic expansion valve is relatively simple. It consists of a metallic valve body that houses all the internal components. Inside the body, there is a metallic diaphragm or bellows, which is the main controlling element of the valve. Above the diaphragm, a spring is installed. The force of this spring is adjustable using an adjusting screw, which allows the technician to set the required evaporator pressure. Below the diaphragm, there is a valve seat with a small opening, orifice. This opening is controlled by a needle or stem connected directly to the diaphragm. When the diaphragm moves downward, the needle also moves away from the seat, opening the valve and allowing refrigerant to flow. When the diaphragm moves upward, the needle moves toward the seat, restricting or closing the refrigerant flow. The needle and seat together form the orifice through which refrigerant passes. Working principle of automatic expansion valve. The working principle of an automatic expansion valve is based on a balance between spring pressure and evaporator pressure. The spring pressure, along with atmospheric pressure, acts on the top side of the diaphragm and pushes it downward. This downward movement causes the needle to move away from the seat, opening the valve and allowing liquid refrigerant to flow into the evaporator. At the same time, the evaporator pressure acts on the underside of the diaphragm. If the evaporator pressure increases, it pushes the diaphragm upward, causing the needle to move toward the seat and reduce refrigerant flow. If the evaporator pressure decreases, the diaphragm moves downward, opening the valve further and increasing refrigerant flow. During normal operation, the valve reaches an equilibrium position where the spring pressure and evaporator pressure balance each other. In this condition, the valve maintains a constant evaporator pressure, allowing steady refrigerant flow. When the refrigeration system is stopped, refrigerant remains inside the evaporator, creating pressure that pushes the diaphragm upward and keeps the valve closed. When the system restarts, evaporator pressure drops and the valve opens automatically. Features of automatic expansion valve. The automatic expansion valve operates at a preset constant evaporator pressure, which can be adjusted using the spring adjustment screw. It relies only on pressure operation through a diaphragm or bellows and does not use temperature sensing elements. This valve can be used with any refrigerant, provided the system operates under a constant cooling load. Its construction is simple, making it easy to manufacture and install. Because of its basic design, the automatic expansion valve is generally used in small refrigeration systems where load variations are minimal. Advantages of automatic expansion valve. One of the main advantages of the automatic expansion valve is its ability to maintain constant evaporator pressure, which simplifies system adjustment after installation. This constant pressure helps improve compressor efficiency by allowing the use of lower capacity compressors and reducing excessive evaporator surface usage. Automatic expansion valves are also effective in preventing evaporator coil freezing, especially under low load conditions, because they maintain relatively higher suction pressure. Additionally, pressure settings can be adjusted easily after installation, making system tuning simpler compared to other expansion devices. Another advantage is its low cost and simple construction, which makes it suitable for small and low-budget refrigeration systems.